the force itself. Then now put it together. For force, dimension of mass is m. For acceleration is this. Put it together. That is for force. So that for work now, the dimension will now be for force is this. M L raised to the power minus 2 times distance, another L. If you have to put it together, you are going to have M L times L squared T raised to the power minus 2. So this one now is now the dimension of work. M L squared T raised to the power minus 2. That is the dimension of work. Which means before you can get the dimension of work, you have to know the dimension of force and distance. So I'll break it down for you. Before we can get the dimension of force, you have to know the dimension of acceleration. Combine this together to get out of force. Take it back to where we are having the work. Combine with x, then you have the dimension of work. That is how we write the dimension of a physical quantity. But so don't forget, all these three will form the basis to write the dimension of any of your derived quantities. So let's consider energy, work, energy, and your moments. All of these three, take note, they have the same dimension. Because work is force times distance. Energy is also relating to work. So if there are sometimes we have to define power, we say energy over time or work over time. I want to believe you still remember that. So work and energy, don't disturb yourself. If you are told to find the dimension of a particular quantity, like energy, they have the same dimension. What about moments? They have the same dimension. Because moment is defined as force times perpendicular distance. Force times distance. Force times perpendicular distance. So if you try to find the dimension, you are still coming back to this. So I intentionally put these three together for you so that you won't disturb yourself. Whenever you are told to find the dimension of any of them, they have the same dimension. Take note of that. Then let's quickly consider pressure. Is force over area. Force over area. I will not want to disturb ourselves on this. We have get the dimension of force. Can you see? Just bring it here. M L then raised to the power minus 2 area. Your area is length times breadth. Now I've told you, whenever you see length, you see breadth, you see height, you have distance, they have the same dimension as what? L. So the length is L, breadth is another L. If you put it together, we have L squared. So M L then minus 2. When this one moves up, we have L minus 2. M, this is about 1. If you use your indices, the law of indices, okay, this is number 1, this is minus 2. We have L raised to the power minus 1. Then we have T raised to the power minus 2. This is now the dimension of pressure. Then let's quickly consider stress. Yes, take note of this also. You remember what I told you about work, energy, moment, they have the same what? Dimension. The same thing with pressure. and stress. Both pressure and stress, they have the same dimension. Okay? Because pressure is defined as force over area. Stress also is defined as force over area. So don't disturb yourself, just take note of the two. The two quantities have the same dimension. If they are told to give the dimension of stress or tensile stress, both of them are the same. Either they call it stress or they call it tensile stress. Don't disturb yourself, both of them are the same. And that one we gave you stress is equal to force over area. And this one is equivalent to that of pressure. It's equivalent. They are the same. That means we have the same dimension. Take notes of that. What about Young modulus? Please take note of this. Young modulus. You can be asked to write the dimension of Young modulus. It's defined as stress over strain. Can you see that? Stress over strain. For stress, let's take it once again. I said it's force over area, and for force, the dimension is M, L. For force, you remember, then force is MA, and the dimension is M, is capital. The dimension of mass is capital M. The dimension of acceleration is LT raised to the power minus 2 divided by area, and the area is what? L squared. When you take it together, we have M, L raised to the power minus 1 raised to the power minus 2. This is the dimension of stress. Okay? If you are not to write the dimension of Young modulus, what are we going to have? Young modulus is, this is the symbol. Stress, which is M, L minus 1 raised to the power minus 2. Therefore, strain. Strain is defined as extension over original length. The ratio of extension to the original length of a material is strain. And extension is meter. Either original length or length is also what? Meter. Meter cancel meter, which means strain has no units. And once it doesn't have units, then strain have no dimension. Which means it is the dimension of stress that will give us Young modulus. Can you see that? It's the dimension of stress, which is this, that will give us Young modulus. So this is the dimension of Young modulus. This is the dimension of Young modulus. Take note of that. It's very important. Then let's quickly see that of surface tension. How do we define a surface tension? Simply, it is force per unit length. And how do we write that? It's as simple as force over length. Can you see that? Force over length. And what is the dimension of force? From here is M, L raised to the power 1, then T raised to the power minus 2 over length. What is the dimension of length? Capital L. Having L cancel L. Then what we are having is M raised to the power minus 2. And that is the dimension of surface tension. Can you see that? Force, dimension is this. Length, dimension is this. L cancel L. What you are having next is M raised to the power minus 2. That is the dimension of surface tension. Finally, let me quickly take power. power. What is the formula for power? That is the first thing. Power is work over time, or you can say energy over what? Over time. That is, before we can get the dimension of power, you need to get the dimension of work. And I have done that for you the other time, if you can still remember. Work itself, again, please look up and see, work itself is force times distance. For force, I have written the dimension of force for you. For force is ml raised to the power minus 2, then times distance, which is another L. The dimension of distance is L. Put it together. M, L times L, L squared. So this is now the dimension of work. But you remember that where we are going is power. But we have to get the dimension of work, which is this. Write it there. Let's see. M, L, L squared minus 2 over, now divided by time. And the dimension